Ahoy, welcome to Prague and welcome to another episode of the Mars Guide. Now in this episode we're going to look even further at the astronomical clock. Now as you would have seen in the last episode, just before the clock goes you will see people gathering here to watch it, and they see the spectacle and they watch the skeleton pulling the bell, and they see the head movements of the moving statues, and they see the apostles coming around in front of them, and when it's over they say, "Is that it?" As I said, this has been voted one of the most disappointing tourist attractions in the world. But it wasn't built as a tourist attraction. So what does it actually do? Well, that's what we're going to find out. As you can imagine, it's hugely complex. It tells you 4 different types of time. It shows you the position of the sun and the moon relative to each other as they move through the constellations of stars in the sky over a year, and for the moon over a month. It shows you the phases of the moon throughout the month, going from a full moon through to a new moon. It indicates the summer and winter solstices. It shows you the autumnal and vernal equinoxes. It tells you how many hours of daylight you've got left in a day and the approximate time of sunset. Not bad for a clock that was built over 600 years ago. But what does it all mean? What do all these dials and these numbers and colours represent? Well, that's what we're going to explore in this episode, and hopefully by the end of this episode you will be able to understand the clock more fully, and you should be able to look at a photograph of the astronomical clock and from that determine the time the photograph was taken, the day of the month it was taken, how many hours of daylight there were left in the day, and the time of sunset. And you can check your answers on Google. Okay, so I'm going to start by using this image of the clock, and we're going to use this image as an example of how to interpret the clock later. Now, one of the problems of creating this clock is how you take something that is three-dimensional, 3D, like the globe, the world, the celestial sphere, and the constellations, and reduce it down to a 2D surface that is the canvas of the clock, while at the same time maintaining the important aspects of the astronomical geometry. Doing this is called stereographic projection. Now, I'm not an astronomer, a mathematician or a geometrist, so my apologies to the experts, but I am trying to keep this simple. But there are some regions that we actually want to display on the 2D surface, and these are the Tropic of Cancer, the Equator, and the Tropic of Capricorn. Why? Because the Tropic of Capricorn is the most northerly circle of latitude on Earth, at which the sun can be directly overhead, and the Tropic of Capricorn is the most southerly circle of latitude at which the sun can be directly overhead. Now, when the sun touches the Tropic of Cancer, it is the summer solstice and marks the start of summer. And when the sun touches the Tropic of Capricorn, it is the winter solstice and marks the start of winter. As you'll see, the sun of the clock moves between these 2 points, and the movement of the sun on the clock represents the path the sun takes through the year, and it is known as the ecliptic, which we'll come to later. It was important to preserve these points on the clock. So in this representation, we are pushing the Earth flat against the backdrop or canvas of the clock and preserving those theoretical marks such as the Tropic of Cancer, the Equator, and the Tropic of Capricorn. On the canvas, in the blue area above the red area, or orange as it used to be, are some words written in Latin. To the left is the word ortus, meaning sunrise, and to the left is the word ocasus, meaning setting. As the sun rises in the east and sets in the west, it means that east is to our left and west is to our right. Because we're looking at the southern sky, it means the south is at the top of the clock and north is at the bottom. Now, there are other parts of the canvas that we need information about, in particular the horizon, because it gives us information about the sun, the moons and the stars when they rise and when they set. Now, it's not truly night until the sun is 18 degrees below the horizon, and it's not truly day until it's 18 degrees above the horizon. But as we know, before sunrise there is dawn, and before night there is dusk or twilight, and these are represented on the clock today in red and formerly in orange. So night is represented as black, obviously, and day as blue. Many centuries ago, the astronomers noted that every year the sun took the same path through the sky, through the same group of stars or constellations. Now, constellations are just groups of stars, and the astronomers did this to make them more memorable and recognizable. And some of them they named after animals, like a lion, Leo, or a crab, Cancer, astrological signs that you would be familiar with. So the astronomers mapped the movement of the sun through what's known as a celestial sphere, and the path of the sun is known as the ecliptic. These constellations have been replaced by the signs of the zodiac and put onto the small dial of the astronomical clock. As I pointed out in the last video, these used to be represented by the pictures of the animals of the zodiac. Also, you can see on the small dial of the astronomical clock there is the sun and the moon, and the sun and moon progress through the various constellations. Now, half of the moon is coloured silver and the other half black, and it allows the clock to indicate the changes of the moon throughout the month. In this picture you can see that the moon moves through the various phases from new moon through to full moon and back to new moon. The moon moves in the opposite direction, but also quicker because it orbits the Earth over 29 days and 13 hours, and of course, from the moon we get the month. The smaller wheel or dial is divided by 4 spokes into 4 different areas, 2 large and 2 smaller ones. These represent the seasons: summer, autumn or fall, winter and spring. Over the year the sun moves vertically down and up the central spoke. At its height, on June the 22nd, the sun touches the outer ring of the Tropic of Cancer. This is the summer solstice and marks the beginning of summer. Over the year, the sun moves vertically down the central spoke and passes through the various constellations on the wheel until at the bottom it touches the inner ring of the Tropic of Capricorn on December 22nd. This is the winter solstice and marks the beginning of winter. Over the next 6 months, the sun moves back up the vertical spoke and through the remaining constellations. The reason it can do this is because the wheel is eccentric. By that I don't mean that it has a rather odd behavior, but that its axis is not placed centrally. The spokes on the inner wheel also show the autumnal and vernal equinoxes. An equinox is the time when the sun crosses the equator, once in autumn and once in spring, and at an equinox the length of day and night are equal. The wheel is also divided into 72 sections, so that each section represents about 5 days. This is important to remember since it helps us to be more accurate when trying to determine the day and the month that the photograph was taken. It's now time to introduce the hand pointer, which indicates 2 types of time on the astronomical clock. That is Bohemian time or Italian time and German or Sibyl time. The last thing to mention on the wheel is the small 6-pointed star that sticks out from one of the spokes. This represents sidereal time or sidereal time. Now, I've heard it pronounced in both ways, but I'm going to stick with sidereal time. So a sidereal day uses the stars to fix or determine the length of day, which is different from a solar day, which uses the sun. A sidereal day lasts 23 hours, 56 minutes and 4 seconds, about 4 minutes shorter than a solar day. And what it represents is one full rotation of the Earth on its axis. Now, the reason why the solar day is longer is because we have to take into account that the Earth goes around the sun, and we're measuring the sun from the same position at the same time every day, but we have to wait for the sun to get into that position because of our rotation. Now, because a sidereal day is shorter, there are 366 sidereal days in a year, but only 365 and a quarter solar days. So that's why every 4 years we have to make up an extra day through a leap year. The first time is Babylonian time, and Babylonian time was used for centuries by Greeks and Romans. In fact, Babylonian hours are mentioned in the Bible. Now, with Babylonian time, the length of an hour can vary over the year because it's derived from the amount of daylight, which is divided into 12 equal lengths. So in the summertime, a Babylonian hour is longer than a Babylonian hour in the winter. And this Babylonian time is represented on the clock canvas by 12 separate blue sections and the Arabic numerals. The next time is Bohemian or Italian time. It has been used since the Middle Ages and was adopted from Italy, hence Italian time. It is represented by the outer ring and the figures are written in gilt Gothic Arabic numerals. The hand pointer points to Bohemian time. Bohemian time runs on a 24-hour clock but starts at sunset, and therefore the hand pointer of the Bohemian dial can tell you how many hours of daylight there are left in a day. German or civil time came to Bohemia from Germany, and it is a system that we are now familiar with. So it is shown in Roman numerals with 12 midday at the top and 12 midnight at the bottom of the clock. Now, I'm not going to talk any further about sidereal time or Babylonian time, since they're not going to help us with trying to identify the time and day and month that a photograph was taken. So, back to our video. How do you apply all the information I've just given you? How do you look at a photograph of the astronomical clock and from that determine the time it was taken, the day it was taken, how many hours of daylight left in the day, and the sunset? Well, let's go back to our original photo. Well, firstly, we can see where the sun is, and the sun is on the little wheel, and it's sitting in Taurus, the star sign of Taurus. Now, Taurus starts on April the 20th, and as I said before, each of these little sections on the wheel represent about 5 days. And looking at this here, this sun has moved for approximately 4 sections, so we're looking at it's about 20 days. So if we take the 20th April plus 20 days, our estimated day that this photograph was taken was on the 11th of May. The time, you can get it from 2 ways. If you look where the hand pointer is at the top, you can see it's just past 9 o'clock on Bohemian civil time. But it's not very easy to see because it's actually partly hidden by the small wheel of the clock. But another way of telling the time is if you go to the bottom, you'll see there's a little T at the end of the hand pointer, and this confirms the time. Okay, I know it's 12 hours ahead, but we're working on the German time. So again, it confirms it's around about maybe 9:15. So the photograph was taken at 9:15 on the 11th of May. The next thing to look at is that the hand pointer is pointing to 14 hours on Bohemian time. And if you recall, I told you that Bohemian time starts at sunset. So because it's pointing to 14, and we know that sunset begins at 24, it means there are 10 hours of daylight remaining. This means that the sunset is going to occur around about 7:15. In our summary, we would say the photograph was taken around 9:15 in the morning on the 11th of May, and the sunset on that day will be 7:30. So looking at Google for sunset on the 11th of May 2020, I see it says 8:37, which means I'm about an hour out. But of course, you have to remember there's no adjustments made to the clock for daylight saving. So if your photograph is taken after the 3rd week in March to the 3rd week in October, then you have to add an hour. So if we go back to our summary, the photograph was taken at 10:15 a.m. on the 11th of May 2020 with sunset around about 8:30 in the evening. And now it's time for the clock face challenge. Using the information I've given you during this episode, have a look at this picture of the astronomical clock face and see if you can tell me approximately the time the photograph was taken, the day, the month, the hours of daylight left in the day, and the approximate time of sunset. And leave your answers in the comments section below. So when people have seen the clock and I've told them about the clock, I say to them, despite its beauty and magnificence, it has got one huge mistake. And I ask them what they think it might be. And they say things like, doesn't tell the time, or daylight saving, or leap years. No, the thing is, when they built this clock, the belief at the time was that the sun went around the earth. It was only about 200 years later where the present ideas about planetary motion that came from Brahe and Kepler, which we talked about previously, were accepted. And there we are. That completes our 2-part look at the fascinating, beautiful, magnificent, complex astronomical clock of Prague. If you've enjoyed coming around with me on this video and you'd like to see more, please don't forget to click and subscribe and press that little bell so that you get notified about future episodes. So, on to the next episode. the beautiful Estates Theatre. And in the next episode, we're going to talk about its association with the world-famous genius composer Mozart, who loved coming here to Prague, and its association with the nationalist revival here in Prague during the 19th century. So until next time, thank you for watching.